that.
Understand, master? What one question?
Yeah, sir. Now, if you wish to understand,
What have I told
because when you look at the objectives that you said we should able to understand, you said we should understand what meteoroids are, how the elements are arranged on the periodic table. Now, the question is, how can you tell that, for example, under meteoroids, how can you tell that this is a metal, this is a non-metal under meteoroids?
Metalloids
That's my question, sir.
Properties that are intermediate, meaning they are just in the middle. So there are properties that are intermediate of those of metals and non-metals. How can you know that this is a metalloid? You look at where it is on the periodic table. There's that zigzag. I think you've seen that zigzag at the end where there's a zigzag. And the metalloids, the beauty is that we've listed them. There's boron, silicon. So there are not so many that you can go to master. Are we together?
And then another question, sir.
Yes.
Yes, sir. I have another question. In group 3 of the periodic table there, where we have aluminium and other elements, there are different elements there. We have metals and non-metals, not so, sir?
Group 3. Let me look at it. We look at metals from a practical perspective. Huh?
Yes. And then, sir, now the question is, since we have mixed elements, metals and non-metals, now how can you tell that this is a metal, this is a non-metal, just from group 3? Because we know that group 1, all of them are metals. Group 2, all of them are metals, but group 3, they are mixed. So how can you tell that this is a metal, this is a non-metal?
Well, mixed are mixed. The only one which is there is boron, which is a metalloid. Tell you. These other ones, we still do not have so much information about them. Gallium, indium, and thallium. We can't really specify and say this is group 3 and this is a metal. How can you know? I've already told you that a metalloid, just by the side of boron, there's a zigzag there. Everything on top of the zigzag. So boron, you come to silicon, then there's germanium, arsenic, antimony, tellurium, polonium, and astatine. So those are the metalloids. You can even see them. So it's not really like your job is not really how you can tell, how you can do it. Your job is to understand the trends and the oxidation numbers. That's your job. Your job is not to get yourself confused with how can I understand? How can I know? No. Periodic table. There's this zigzag on this periodic table. The zigzag, I don't know if you can see this.
Yes, sir.
This. I'm sure it's here even on the other periodic table there. So these ones,
yes,
they are aluminium. All the other ones are metalloids in that zigzag. So just try to understand from that perspective. Good morning. Let me
last
meet
question,
you.
Sir.
Yes. Yeah, my question. Yeah.
Last question, sir.
Okay, yes.
Sir, in the notes, there is somewhere where I read it say elements on the periodic table are named according to their complicity. So I don't understand what it means.
I'm gonna avoid word fail actually. Yes, mom. What you want to avoid that complexity?
Let me say yes.
What you want to avoid complexity? What you want to avoid complexity? One for Davis.
Yes, sir.
Complexity is from the word complicated. Why? Meaning we arrange metals from simple to complex. So in the arrangement, the number 1 is the simplest, meaning the lightest there, which is hydrogen. Number 2 is the second lightest, which is helium. So like as you go on the periodic table, there's that increasing of the atomic numbers. I'm sure you've seen. Or even the masses, the atomic mass also increases as you go on the periodic table. So if you are listening, which one is number 1? It should be hydrogen. Number 2, helium. Number 3, lithium. So I'm sure you know that's what you mean when complex. Like if your girlfriend, if you say it's complicated. Facebook, it's complicated. It's complicated. Yes, so we arrange them from simple to complex. So I think I can start. Stephen, guys. Not to Amba, but
That's one, sir.
Yes. Okay, but Tatawa Davis, I can't close your mouth, so let me get your question. Yes.
Me, what I thought of was the word complex.
Yes.
To complex was, yeah, like to put something together in its tight particle, in its tight form, say so. That's what I thought of.
Oh.
To complex.
So, what's the complex? Yeah, chemistry. It means you have so many things.
Yes.
But for the complex, which we said in order of complexity, it's by mass. It's by mass.
Okay.
Yes, so that's the complex. The bigger, even the more.
I'm clear now.
Yes. So, guys, as Davis has guided us, the periodic table is simply the arrangement of elements in an organizational and classifiable manner. But just the arrangement of elements. No one will ask you in a paper to say, define periodic table. Your job is to know how to use it. Your job is to understand certain trends. Especially, you should know which one are the alkaline metals, which are the alkaline earth, which are the halogens, and which are the noble gases. You must be able to know those cases. So now, if you look at the periodic table itself, some of the stuff already said that of elements that are known, the periodic table that is representative. So of the elements that are known, 2 are liquids. So you can't know really the state on the periodic table unless you are using an advanced one. So the liquid, who remembers the liquid elements on the periodic table? Who remembers the liquid elements? Yes.
So there's bromine.
Yes, bromine.
And mercury.
And mercury. Thank you very much, Mr. Mansa. That is that's the truth. Then we also have 11 which are gases. We also have 11 which are gases. Who remembers the gases? Just 2 or 3. Who remembers which one is a gas? So those are the things you must be able to know. Nitrogen and
chlorine.
And chlorine. Those are gases at room temperature. But I was expecting oxygen, guys. Do you know about oxygen? Is the air is what we need for our respiration. You are my oxygen.
Oxygen is common.
Yeah.
It's not common, but it's common. It's very important. So those are, you can tell your girlfriend, you're my oxygen. I can't live without you, baby. Mambale? Na mambale? You can even tell your guide, say, ever since I met you, I started breathing clean. You are the purest form of oxygen for me. You can say that. Why am I?
Inyabe kuboka hydrogen.
You'll be using chlorine, man. Sir.
Oh, we can't breathe using chlorine. It's
Tumfaba
poison.
kiasi na tumfaba kiasi.
Eh? Okay. The arrangements of elements is that you have columns and rows. So the columns of the periodic table are called the groups. And elements in the same group, my internet is tripping a bit. The columns are called the groups, and the elements in the same group have similar reactivity, meaning the way they enter the reaction is just that some are more reactive and some are less reactive. E.g., if we look at group 1, where there's lithium and francium, so the most electropositive element on the periodic table is francium. It's the most positive. Its reactions are explosive. You can't even find it in nature. Like you can't go with francium in the lab. It will already have reacted with the air outside. But lithium, you can have it, but it also explodes, but not so much. But a reaction of lithium, or francium or cesium, those are the last elements in group 1 at the bottom. When you want them to react, you take somewhere at a distance, then you come back, and it will explode like a bomb like that. And you need to react it. If you don't want that big explosion, you have to react very small quantities of that. But all the same, you will see that there's a reaction which is very explosive. Why? Because those are more reactive. So as you go down the group for these elements, for metals, as you go down the group, they become more reactive. They become more reactive. They become more electropositive, meaning the electronegativity decreases. So those are the terms that we'll talk about electronegativity properly when we go, but we just want to go to compounds first. Then, so those are the aspects. So the groups have the same reactions, meaning the way lithium will react with chlorine and the products, you can actually speculate when someone gives you potassium. It means they will form the similar, like lithium chloride. When you get potassium chloride, you just write the same kind of reaction. Why? Because they react the same way. Even the halogens is the same. So those are the reasonings that are there. So in a same group, the elements have similar properties, except the transitional elements. Why? Because those ones are variable oxidation states, meaning the electrons, outer shell electrons, are different. Some of them move out of a certain from one shell to another. We'll talk about that when we talk about orbital configurations. So that's the reason. So groups have similar reactivity, similar chemical properties, and as you go down the group, the electropositivity increases, meaning the electronegativity decreases, and as you go down the group, a shell is added. A shell is added. More like shells, like the energy level is increased for electrons outside the outer electrons. So you always have an extra shell as you go down the group. Then there isn't so much on the period. On the period, what is there is, what can I say? Like on the period, the elements in the same period have, what do they have? They have the same number of shells. That's all. But as you are going from left to right, the electronegativity increases in a period. As you're going from left to right, the electronegativity increases. I'll define properly those terms, but I want you to go and look them up what is electronegativity? Why is it relevant to chemistry? You look them up before you do your first book, and you chat. So do that. So now, on the periodic table, our interest is that on the periodic table you have metals, non-metals, and the most important, Davis, black sheet Davis. What is it? Metals, metalloids. Is that a new term, guys? Didn't you see it at grade 12?
We did, sir.
Metalloids, you saw it at grade 12, too? And then actually, I'm feel college. Nimitafunda sana kuchwala.
It's also my first time.
Oh, Crispin, it's your first time.
Yes,
But Richard, more anande. Like him for the box so good there.
yes,
Madi
yes, sir.
mujet so.
They are also called half metals. Is that true? The meteoroids.
Yeah, they are also called half metals. Yes, half metals, half non-metal. You can say that. So now, the metals are the most abundant on the periodic table. Now we want periodic table. If you have full up, if you have a DVD, FEMA metals. I'm sure my name of FEMA. The most abundant things there, most of the elements you have there on the periodic table are metals. Have you noted? Madimona, guys.
Yes, sir.
So those are the things. So where do we use metals? Where have you ever seen metals being used in real life?
Industries.
Industries are used as, yes. Industries. Where else? In the kitchen.
They also use that.
Like where, Emmanuel? So if something, Emmanuel, you're saying something.
Construction sites.
Construction sites. Yes, Crispin.
They also use as roofing sheets, electric cables.
Roof ya malata. Area kutire mfula nga iri eroka. Iri mpange chongo na phone kote upange. So you find them in a lot of places, construction, automobiles, the engine of a car. Engine. You find so many metals there. I'm sure you've seen. Then you also find them as utensils. Those are the things that you have in the kitchen. Very valuable.
What about magnets?
Also, yes, because magnets are iron. Magnets are iron. So all those are metals. So in real life, you encounter them, burglars, all those things, everything that's metallic. You can't have a building minus having used a metal somewhere. So those are things you must know. So then non-metals, where do you find them? Non-metals. For me, I think non-metals are more valuable. One, you start with oxygen. We said we need it to breathe. Water, you need it to survive because water is made of two non-metals, which is hydrogen and oxygen. Therefore, but what else? Like when you look at non-metals, where do you apply them? Non-metals, who knows where we find non-metals used? Yes, Manu.
In industries as well, so like in terms of making plastics and
yes, plastics
and stuff.
Yeah. Oh, plastic industry.
To fill light bulbs also. Argon. It's argon, eh?
Yes, argon.
Light bulbs.
Argon, yes, you can say it's non-metallic, but those ones we specify it alone as a noble gas.
Okay.
Yeah, it's also chlorine powder is used as what? Liquid bleach.
Okay.
It's also used. as disinfectors.
Disinfectants, mwamushtaka chlorine, tevo. There's also chlorine water you buy, tevo. But most importantly, just food, clothing. Can we survive without those things? Food, clothes, glass, fuel, plastics, wood. Can you survive without those things I've mentioned?
Nope.
No, sir.
Can you? So which ones? But
No,
the things.
no, sir.
So by the things we add value to, are they Normalista observe? We add more value to the metals, therefore.
Yes,
But
sir.
the non-metals are very valuable. As to Wombera Kabwadi, there's a song like that by Dandy Krez. To Wombera Kabwadi. Meaning, like, the reason why you are here is so that you can eat. That's why you're in class. So that when you get your salary, you buy your food. Kuladia man places asuma. Someone takes you on a date to a place where the food is cheap. Those are the things that are there. So now, metallic elements, most of them are solid. As we said, metallic elements are solid at room temperature, except for mercury. Mercury is a liquid metal. I'm sure you know. So that's one of the things we must know. The metallic elements are solid. Because sometimes we will need to be knowing when writing the reactions, you need to know the states. I'm sure you did that at grade 12, the state of the reaction. So metallic elements, most of them are solids. Then they have high luster and are good conductors of heat and electricity. What does it mean? High luster. Einmal. They have high luster and are good conductors of heat and electricity. They are malleable and ductile. Who wanted to answer for the high luster? Gertrude. None will ask about the high luster. What does it mean? Go and look it up. Huh?
They are lustrous, sir.
Boy, high luster, they are lustrous.
They don't.
Who define what it doesn't mean?
They don't trust. More like
How
they don't react.
Guy, move for it. Ulol mean one day. Chilanja to rasta. Ndanja to lasta. What so?
So they don't trust. They don't go trust.
Wa get road. Ndemi what na mumpa chinchilanja to rasta ndanja to lasta. I said the lasta meaning Luster. Not
STR.
Go and look it up. Luster. High luster. Mambole.
Can I try, sir?
Yes. Zimbabwe.
I think it has to do. Huh? Yes, with Zimba.
Ruthie.
Oh, yes.
Kaipa pesa pa typhoon. Yeah. Yes, yes.
I think it has to do with how they are shiny and they can reflect, something in those lines.
Okay. Go and look it up some more.
Can I try, sir?
Sir.
Paul. Is it Paul?
Sir.
Yes, Paul. Yes, you're saying?
Yes, I want to try. Rust, from what I understand, yes, from what I understand by the word rust, it's more like from what Gertrude she was from saying, like they are shine whereby they don't rust first, whereby they've got tingarawa first. Wow.
Okay, actually, if you go and look it up.
High luster.
Rust and dust are different.
Melting
Which
point.
one? Because there's the
The
one
melting
which
point.
has to do with rust, and last the one what has to do
Okay,
with
guys.
Let's
it
has
being
clarified with you
Because
stronger.
the
guys
spelling is the
saying.
same. Because the spelling
No, the
of
spelling
us.
isn't the same. The
It's
Right,
Is
but
it the
different.
same?
It's different.
It's different.
rust.
it's a very good argument, guys.
Rust and
I
Okay.
last
want
are
the
different. Now,
class to
which
be
one
like
is
this.
he
Last, but they're
saying?
different. Come
Guys,
on.
now let's
Sir, which sir, which one are you saying? Last or rust?
He's saying
last.
last with an L. That's why he said it's not rust. Rust meaning when it starts to do like it's falling.
For if it's the one for L, the what I understand
man.
is that it means something that's strong and that's full of vigor. Something that's full of vigor.
At
What
high
does the word
luster.
vigor mean?
Can I share my thought?
Go then.
And I think the high thing you're talking about has to do with the melting point, so something like that maybe. Let's try.
I feel the simplest way to talk about the luster is probably based on a material, whether metallic or non-metallic, in that way. I don't know.
Yeah,
but I feel I can explain, sir.
Okay, now. Guys, you go and look this up.
I explain.
No, you look it up. Guys, so I want to explain some more. Because we style up. Are we together?
Okay, sir.
Go and look it up.
Yes, sir.
Louster. Remember that? Louster.
Yes, sir.
Go and look it up. So, one of the things you must know is that metals have high melting point, more important, and high density. High melting points and high density. Definitely, it also means high boiling point. But since they are solids, so the transition from one stage to another, for them, the transition is melting. So we say they have high melting point and high density. So the densities of these things are very big in kg per meter cubed. You find gold is 19,300 kg per meter cubed. Nadish ba gold kind of fire chuma. Ngana ikwata fe na umfabwen. Okay, so those are the things. So you must know some metals that are there, like gold, the one I mentioned, copper, the one Zambia depends on iron, lead, magnesium, the same mercury mentioned. You must be able to know these things. So try by all means all the time to have ideas of what these metals are. And metals don't react with each other. Metals don't react with each other. It's like, yes, metals don't react with each other, but they readily react with non-metals. They readily react with non-metals in ionic bonding and to form ionic compounds. So that's the reason in there. So always, that's the most important point we've said today, that metals do not react with each other. They don't readily react with each other, but they react with non-metals, e.g. chlorine, oxygen, nitrogen, those things. They react with those to form ionic compounds. So try by all means to think in that perspective. So I think enough of the metals, because there are so many metals that are there in the world. Then non-metals are non-lustrous. Non-lustrous. They know what to stand up. Yeah, last. Then they have relatively low melting points and density, or relatively low boiling points and density. Then some metals are gases. I'm sure you remember the ones we've said, which ones are gases: hydrogen, oxygen, nitrogen, halogens. So those are gases. Then some metals, some are solid. First of all, there's gases, the ones we listed. Then there's bromine, it's a liquid. The rest are solid. So you must know that. So one of the common metals, non-metals that we know is carbon. You did graphite and diamond, blood diamond. Nga wadikwata feo nani yo diamond. So carbon tiyaba di ilasha, tiyaba ni diamond. Ilasha eri achipafye, but futi diamond. So you can see that carbon is very vital. It's a composition, it's one that makes our skin pigments, most of the things that we love about ourselves. This carbon, your melanin, most of that you're looking at is carbon. Then there's nitrogen, oxygen, sulfur. That ffe twalabako sulfur mwebena mufulirapo muli center eri ayimikola. So those are the things. Then lastly, noble gases can be classified as non-metals, but would rather just stick to them as noble gases. So those are things. Then the thing about non-metals, because I'm very fast, I'm sorry, time here, Pwakofe. I would have loved if we did 2 sessions. I didn't know it was going to be this interesting. Numbakai, I miscalculated, would have done one at 8:30 maybe, another one at 9:30. One of the things, first of all, that I want to say is that non-metals react with each other. They readily react with each other to form covalent compounds. Covalent compounds are also called molecular compounds. Meaning covalent bonding is called molecular bonding because what is formed from covalent bonding are the molecules. Water is a molecule, carbon dioxide is a molecule. So those things that you form from non-metals reacting together with each other, a non-metal and a non-metal, the sharing of electrons is covalent bonding. And that covalent bonding, as I already said, is called molecular bonding because what are formed are molecules. And the beauty with the molecules is that it is like that, like particles, the molecules always move together. So those are the things, like children, they love each other. It's the gossip, son. I'm sure you've seen that. Center yakaya sulfur dioxide is a molecule as well. Organic compounds, your methane, your butane, everything there in organic chemistry is non-metal with non-metal, except where you have just a little where there's a metal and it will combine to an organic structure. Then the last are the metalloids. Metalloids, we already stated about them: boron, silicon, astatine. They have properties intermediate of those of metals and non-metals. So those are the things. Try to understand that. And their use is in electronics. All these electronic gadgets that we enjoy are used, they use metalloids like silicon chips and all. I'm sure you've read of that. Arsenic compounds, the arsenic, the one we've mentioned, arsenic is a good poison. Arsenic is a slow killing poison. Kulabika fya tunono nishulebe pa bashimwana badefu. Paka bafu after 4 months bali kushira na mane yonze. So those are the things. Guys, there isn't time